for the delay there. Hope everybody's logged in. I had a little problem getting the camera set up correctly. But here we are, and welcome to Playing with Light. Today we're going to show you how to do things and explore the world of light in 4 sections. And the first, and probably the longest, is going to be how to make some polarized light art. And to do that, you're going to need one of the kits. Although if you don't have a kit, you can pick one up at the Bexley Public Library after the event. And if you can't arrange to do that, you can always use some at-home items that aren't in the kit, but that will work nearly as well. The kit comes in a little bag, and let me just show you real quick what's in it. First, you have an ordinary blank CD recordable disc, which we'll use to make rainbows. And secondly, and probably the most important, we have something called a polarization filter, or I'm just going to call it a viewer for this little session. But it's very important that you keep this and not touch the gray area. Just hold it by the edges. So that's your polarization viewer. And in addition, you're going to have in the bag 2 of these small beads, which are actually sensitive to ultraviolet, a type of invisible light. And you're also going to have, and don't lose these because they'll be really useful in getting you started on some artwork, some pieces of ordinary packing tape that you can use to get started with your exploration. So the first thing we're going to do is I'm going to turn the camera around, and bear with me one second. I move some wires. I'm going to turn the camera around, and we're going to look at an ordinary computer screen. And this is another item that you can use with your kit. And let's see, let's get it right there. Okay. And I've got this screen set so it doesn't have an image on it. It's just white. Okay. And I'm going to take my viewer, which you can see, and I'm going to hold it over the camera. And I want you to watch what happens. You can see some images start to appear. Let me use this other one here. As I rotate the viewer in front of the camera, you see these colorful images. One of them looks a little bit like a bird. One of them looks a little bit like a butterfly. And here I made one just before today. We'll take a look at this. I'll just stand him up over here. Whoops. You see it looks a little bit like a dog. And as I rotate, you can see different features show up. The colors change based on the rotation. And you can even make a little animation. I think you can probably see how his mouth is starting to open up a little bit, or at least appear a different color. Now, let's examine one of these images up close. All it is a piece of cellophane tape applied. I think you can see it. Now let me turn the camera around so I can show you how to make it. Okay. This cellophane tape, you take an ordinary, like a pocket protector, some kind of clear plastic, and then you take a roll of tape. You can use Scotch tape, but it must be the kind that's perfectly clear, not the satin finish, so-called invisible tape. And all you do is peel off a piece of it. And let's just do one and see what it looks like. I'm going to take another piece of plastic, and I'll put the tape on just on one side. And I'll turn it around. Okay. And let's look at it against the background of the screen. Excuse me. Sorry, didn't hold the viewer in front of the screen. There we go. And as you can see, when I turn it, it takes on different colors. In fact, it appears in some angles, I can either turn the drawing or the item I'm designing, or I can turn the viewer. Either way, it's going to change the colors of the image that you see. Okay, so a couple of ways you can do that. Probably the easiest when you start out an art project is just draw a little sketch on a piece of paper until you get it the way you want. Then take a piece of plastic and hold it over the sketch. And then it's helpful if you take some tape pieces that are pre-cut, and you can either tape them directly on around the outline of your item, or you can glue them on. You can use any kind of clear glue to do that and build up your design. Now, one of the things that's kind of cool about this tape, what I've done here is I folded it over so it isn't sticky on both sides, so I don't get it stuck to everything. But if I turn the tape and fold it, say make 3 layers of it, fold it over like this, and I look at it through my viewer. And let's get this out of the way so it doesn't distract. If I look at it through the viewer here, you'll note that the different layers have different colors. And as I twist them, those colors take on, very beautiful tones, which is pretty interesting, I think. Now, you can imagine if you set a large screen TV across the room, and you take a fairly large piece of clear plastic, like I'm holding in front of me here, and design your tape pieces so they will show up in an interesting, it could be a geometric design, or it could be an animal, flower, a landscape, any number of things. And then you hold this up to your eye, and this can be 20 feet away, just kind of mounted in front of the television screen or a computer monitor. And anybody in the room who has the viewer can just hold it there. And as you twist it, you'll see your artistic creation come to life and maybe even animate itself. Now, if you don't want to get into the art stuff right away, there's a couple of other interesting things you can do with your viewer. And the first thing that you might want to do is just take the viewer and hold it in your hand and look at a pan of water. And I'm going to show you one right here. And I'll just get this out of the way. I've just taken a little really shallow pan of water. And as you can see, you can see a little bit out the window, but mostly you see reflections. Underneath that, however, if I hold this in front, you can see the scene changes quite a bit. And if we're really lucky, when you turn it just right, the picture that's underneath the water will show up. Now, you don't need to create your own pond. What I would suggest is you can go out in your driveway with your viewer and look at a car, look at the windows, look at some of the plastic pieces, and just view the reflections from the sky, for example, with your viewer, and you'll notice that all of a sudden it'll take on different colors. In fact, here's another thing you can use. If you have an old CD case, take half of it and hold it up to the sky. Let's see, hold it up so that it's reflecting something, and then view on edge with the viewer, and you'll see multicolors. Let's see what this looks like instead of the sky, since we're doing this inside. I'll do it with our computer monitor. And so here it is by itself, just a plain clear piece of plastic. And you can see that it has fantastic rainbow-like colors as you rotate it or you rotate the viewer. And in fact, if you want to make an extra colorful creation, you can take this as your base and apply layers of tape. And I would suggest probably don't go more than 3 or 4 layers of tape, but you can build up patterns by adjusting the number of layers of tape to get different color effects. Now, there are other plastic items that you might want to investigate. This is just a little flat plastic dish, and you can see that it also shows some interesting color. Here's a little inexpensive plastic magnifying glass, and you can see that, again, it's showing an interesting pattern. I wonder what that does. And here's a plastic test tube, and I think you can see, let's hold it right in front here. Depending on the way I'm twisting the viewer. The important thing is, if you don't see it right away, rotate the viewer very slowly until you get the interesting patterns. You can also, if you have any plastic dishware, notice this is clear plastic until I put the viewer in front of it. Now, what this is telling us is most of these plastic objects were made of hot melted plastic injected into molds, and then they pop them out and they cool really quickly. And when they cool, the plastic doesn't cool perfectly evenly, and those patterns actually tell you the stresses that the plastic is feeling long after it was heated up. So it kind of gives you a history of what that plastic was exposed to. So I'm hoping that everybody is going to take that viewer and give it a try. I don't see any comments on that. If you have questions, use the comment facility, and I will try to answer them at the end of the hour. Okay. Now let's move on to the second item. And here you don't really need your kit. You can work with this with ordinary household materials. And this is what I would call bubbles. Okay. Everybody has blown bubbles, but what we're going to do today is blow. Oh, I'm sorry. I'm going to go back, and I forgot one other thing. If you don't have the kit, you can use sunglasses. And the kind of sunglasses that work are called surprisingly, Polaroid sunglasses or polarized sunglasses. And they, as you rotate, don't wear them. You just hold them like this and examine plastic items against a computer screen and watch them change colors. And you'll see they're extremely interesting. It's a little bit dimmer than you get with your regular viewer, but it will work. Okay, so let's see what we can learn about light and colors. And I'll explain how the polarized light system or the polarizing viewer actually works at the end of our time to get into the science of it. Right now, I just want to go for how to view things. Okay, to look at bubbles, we're going to need a couple of things. The first thing is a cap, and this particular one is a cap from a milk bottle. And we're going to blow a half bubble with that. And the material, my favorite material, it's not critical, is mixing a little bit of Dawn dishwashing detergent with some water, maybe say a half a teaspoon of Dawn and 3 or 4 tablespoons of water is all you need. When you're using a cap like this, you don't use up very much. And then get an ordinary straw, and I'll show you the bubble that you get. Let's move this around so it's close. And probably the most important thing for bubbles is to get a good background. And I want to make sure you can see this. As I say, my camera is acting up, so there we go. And notice I've just put some black material behind it to block out light that I don't want to see. Again, I blow the bubble, and it's kind of interesting to just relax for a moment and watch it develop. And what you'll notice is that you're going to see bands of rainbow colors. You're going to see your red, yellow, green, blue, violet, and so forth form horizontal bands. And I'm going to turn off the fan so I don't blow it around. And if you look very carefully, let me get a little bit closer. Okay, can you see that? You see how it's starting to swirl a little bit. And if you want, you just take your straw and blow on the edge. Whoops, blow on the edge gently. And that will accelerate the spinning and swirling. And then what I think you'll find very interesting is if you look at a weather map of the Earth's atmosphere, like especially when there's a hurricane or a storm system, you'll see all manner of swirling, which reminds you a little bit about this bubble. And in fact, scientists are using analysis of bubbles to help understand the patterns in the Earth's atmosphere. Also, if you look at the atmosphere of Jupiter through a telescope or get a photograph of, for example, a Hubble Space Telescope photo of Jupiter, you'll be able to see some interesting similarities in the way those patterns develop. Now, the other thing you can do is to take a very bright light. I'm going to use a flashlight, and you don't need it to see it directly, but obviously, you can see, you can isolate one color and watch it kind of gradually go down the edges of the bubble. But I'm going to turn this around. I'm going to turn the camera around and look at a white card. Whoops, you almost saw it. Okay, now you'll see ahead of you a projection of the outline of the bubble. Can you see that? And that projection now starts to take on some colors, and you can see it starts to get, the bands are horizontal and they repeat, red, yellow, green, blue, etc. And they're moving down. And at the top, eventually the bubble will get dark and there'll be no color. And that's where it's thinning out. The gravity is pulling the water down between 2 layers of soap that help form the bubble. And as it gets thinner at the top, eventually that darker area with no color will expand, and you can really predict when it's going to pop. Okay, now I think you can see the swirls starting to develop. And if I blow on it very gently, There you go. You can see it like a little miniature Jupiter. In fact, every time I talk, it takes on a different pattern. So that's something that you can do at home very easily with your bubble maker. Now, this works. Why it works is two things are happening. Whenever you have very thin objects like a bubble, 2 layers of soap with water in between, the thickness of that water layer is so thin that when the light goes through it, it hits one side, some of it's reflected, some of it goes through, hits the other side, some of it's reflected, some of it goes through, but the light actually interferes with itself. And because the white light, from in this case the flashlight, contains all the colors, some of those colors, when they interfere, cancel out, and some of them reinforce, therefore giving you the classic rainbow pattern. Now, some options you can do with your bubble machine is to take an old pop can, and you notice, turn it upside down, and you'll see it's got a depression. Put about a teaspoon of your soap solution in there, blow the bubble in the top, but now put the can on top of a warm object. You could put it in a pan of warm water, or you could use a coffee warmer, something that's not too hot. Don't put it on the stove, but you could put it on a pan of warm water, and that will actually accelerate all those swirling, beautiful colors that you'll see inside the bubble. So that's an interesting thing that I like to observe bubbles and how they develop. Now, next thing I wanted to look at is to show you how to make especially bright rainbows yourself. And you can do this either with a very bright flashlight, although I must say it works best with the sun. And I'm going to hold up some photos that I took of some of the ones that I made with this technique. There you go. You see, those are 2 pictures, and you can see in the center something looks a little bit like your CD. And if you see down here in this area is the actual CD. And what I did is put that CD in a window. Let me get some of this material out of the way. And all I'm going to do is take the CD and place it on a table. And then I'm going to take a very bright flashlight, and this is going to stand in for the sun, okay, for this purpose. And you see how it's ranged at a very steep angle. And when I turn it on, now you can see, I think, quite a spectacular rainbow effect that can be achieved. And you can move it around by just shifting, of course, the direction. Now, if you want to use this to pick up the sun, you can actually make something that's a little bit, and I want to point out before we move on, we've got our red, we've got some orange, we've got yellow, green, blue, and violet. And I wonder if there are other forms of light, what lies beyond the red and what lies beyond the violet. And in just a few minutes, I'll share with you some techniques that you can use to view things that are out here that are normally invisible to your eye, view things that are here, and to view things that are here, and to actually use those. But let's show you how to make a little stand. And what we have is simply tape a straw to the back, not the shiny side, the back side of the CD, stick it inside another straw. It can be a slightly larger straw, or you can compress it, and tape it to another piece of cardboard. I've just used a white card here, but it can be any kind of cardboard, doesn't matter. And you can see I've made a little slot here so it kind of stands up on its own, and tape it at a little less than a 45-degree angle. So if you had a diagonal across this, make it a little less. That's actually a 40-degree angle, which makes it work particularly well. And what you do is you point that straw, I'm sorry, here, I'm going to point it north, okay? And during the day, you can rotate this around. Whoops, I'm sorry. Let's see if you can see it that way. During the day, you can rotate this around to follow the sun and actually project the image. Let's imagine if it was this way. If the sun is coming in from this side, it rises in the east. If it comes from this side, it's going to reflect it in this direction. If it's at noon, it's going to I'm sorry, it's this way. If it's at noon, the sun's coming in here and it's going to reflect it back. And then at 6 o'clock in the afternoon, the sun is going to be over here coming in from this direction, and it can be made to aim it at the same spot. So you can use this to make your own kind of a reverse sundial. And every hour you change the location of the rotation of the disc so that it catches the sun and throws it against your wall at the best possible time. Now, it's kind of hard to do this outdoors. If you have a north side of your house, for example, that's a light color, or if you have you can use a poster if you want, or a white piece of paper. It has to pretty much be in shade. You don't want to do this in bright sunlight because it washes out. And I've got this room partially dimmed. The darker your room, the bigger the effect is, and you'll be able to get images that look like these. And these are several feet in diameter, so they're quite large. The ideal room has a window that faces south, so it's going to be seeing the sun a good part of the day. Okay, so that's how to make super rainbows. Now, if you're going to use a flashlight, there's two kinds of flashlights. You want to use a strong one, first of all, but the flashlights that have a focusing mechanism, see how I slide this back and forth? When it's focused for a far distance, it behaves much like the sun. You want the light waves to come out parallel in a narrow diameter as opposed to going at an extremely wide angle. It will work either way, but the results are more spectacular with a flashlight. However, the sun is perfect, okay? You just have to find the right window to do that. Okay, that's the CD Rainbow Maker. Now, I promised that I would show you some invisible light. And let's see what we have that might be invisible. You probably all have one of these at home. It's a remote control. And all I'm going to do is shine the remote control at the camera and see what happens. Whoa. When I press any of the buttons, you see the little lights come on? And the reason for that is this is called an infrared remote. Now, there are different kinds of remotes. Some of them use radio waves, which is actually another form of light, but this trick won't work on it. So you want to use an infrared remote, and you can tell if it's infrared. It's usually going to have one or two LEDs in front or a little clear window in front. And you can either use this is a Chromebook screen. It'll work equally well on many smartphones. If you aim this at a smartphone camera or a digital camera, it turns out that cameras have a much wider range of vision and they can see beyond the red. It's called infrared, which means beyond red, or think of it as redder than red, invisible to the eye, but not invisible to the camera. Now, in fact, I'm going to take a little black piece of plastic. It looks black. And I'm going to take an extremely bright light. And this is a laser pointer. I think you can see, how bright it is. And I'm going to aim this directly at the camera. And you see that hardly anything comes through. It just barely lets this very bright laser light, oh, there it came through. But if I hold it up to my eye, or if I hold it up to the camera, you can see, all you see is a little bit of blue light reflecting off something in the background. But if I hold this up to the screen, you notice you're not seeing anything except when I'm pressing the button now. You can't see anything else except the light, because this is a filter that blocks almost all forms of light except infrared light. Okay, so that's one end of the infrared spectrum. And the other end is what we call ultraviolet. Now I'm going to turn on another device over here for a moment and show you what your beads, these are in your kit. I'm going to show you what these beads will do. And here I have an ultraviolet light. Now it has a little bit of a blue light, and the camera, it seems brighter in the camera than it does to your naked eye. But if I hold this up here for just a few seconds, you'll notice that those beads have now turned purple. And many of you may have seen these beads before. You can see they turn purple after you shine the light on them. And then they revert after a short while. You see that purple color? Let's take it out of the bag. Let's take out one that hasn't been hit yet. And I'll just hold it in my hand, and I'll shine the light on it for just a few seconds. And now you see it's turned purple. Well, the fun part about these is you can use it to conduct some science experiments outdoors. The sun, even though it looks white, has infrared invisible light, and it has ultraviolet invisible light, in addition to all the other colors that we normally see and split out with our rainbow maker. But imagine what would happen if you take this bead and coat it with SPF 50 sunscreen. Any ideas? I wonder if that would prevent it from turning purple. I'd like you to try it. See what happens. I think you might find it an interesting experiment. The other thing, what if you put it in a glass of water and let it sink it to the bottom, tie a weight to it so it sinks to the bottom, and expose it to the sun? Do you think water would block all the ultraviolet rays? Does that mean you couldn't get a sunburn if you were in a swimming pool underwater? It's an experiment to find out. Now you've got two beads, so you can do different conditions with the same light and see what prevents ultraviolet light from going through. For example, I could tape this to my arm under this black shirt, and I wonder if that would stop the ultraviolet rays from coming. What about a white shirt? What about a piece of metal? What about a piece of plastic? If I put that between the sun and the light. And then you could simply use a watch and compare a cloudy day to a sunny day and see how much stronger the ultraviolet light is on one day or another. And you might also find out why it is you might be able to get a sunburn even on a cloudy day. If this turns blue really quickly, make sure you have your sunscreen on. Well, always have your sunscreen on, but anyway, that's a possibility. Now, I want to show you another type of infrared light. And you may refer to it, and I see I have a comment I may have to answer here. Okay, good. I see somebody's tried the viewer on tape, and I'm going to ask you, did it work or not? I hope so. Here you're looking at, oops, let me move my water dish out of the way here. Here you're looking at a coffee warmer. And now you're looking at an ordinary, looks like a piece of plastic. And if I put my finger on it, oh, did you see that? It turned blue. That's because this is called heat sensitive plastic, and it'll turn a color if it gets above about 95 degrees. So your skin is warm enough to change its color. Actually, it's about 90 degrees, I think, because my skin's about 90 degrees. So I've turned this on so that it's pretty warm, okay? In fact, I measured the temperature, and it's about 250 degrees. And what I'm going to do is not touch it. And I think you can see that I'm holding it above but not touching. And let's see what happens. And I'll tilt it up so you can see it in a minute. I'll give it 5 or 6 seconds. And something's happening. I'm getting a little, can you see the little blue smiley face? And if I leave it on there too long, the whole thing will heat up. But it's kind of a very inexpensive thermal camera. And that's because on the back is a piece of paper, which is partially transparent to heat. And then there's another piece of paper with the smiley face image cut, with holes cut that allow you to allow the heat waves to go through. So heat is a form of light. Now, what I'm going to do is I'm going to take this thermometer, and many of you have heard that we're testing a lot of people when they come into buildings to see if they have temperatures, and you don't have to touch them because this is called an infrared thermometer, and it can read things up to about 10 feet away. I'm going to hold it right in front. I'm going to press the button, and I'll let you see it. I don't know if you can read it, but it says 293 degrees. That's kind of interesting. And if I take a piece of paper and hold it between, and you'll see that it's 88 degrees. This paper is not very transparent to infrared light. Some things are. Very few materials are completely transparent. But that's how infrared on that side works. Now, you might be wondering, are there any art projects that you can do with ultraviolet light that don't cost a lot of money? And I've discovered one in my little research that I thought was pretty interesting, and that is the most fun ultraviolet light sensitive material is a piece of black or dark construction paper. The kind of paper that's a little bit rough. It's not completely shiny. Has a dull, rough finish. It's called construction paper. And I want to show you an image that I made in ultraviolet light. And can you see the round circles and a little thread-like thing between them? And all I did is took this outside on a sunny day and laid different coins around it. And then I had a little chain, and I draped the chain around it. And I waited, I think on this one, 1 hour. And what happens is that the ultraviolet rays actually start to break down the dyes in the paper that they use to make it black, and it fades it out very quickly. And of course, this is why it's very bad to have photographs or paintings and so forth displayed in front of an open window where the sun might hit them, because the sun does fade things. However, with construction paper, it happens very quickly, and you can actually use it to make some interesting designs just by laying opaque, non-transparent objects on top of the paper and arranging them in whatever pattern you want, taking them outside. You might have to weight down the edges so it doesn't blow away. Leave it an hour in direct sunlight, and you'll get a pretty interesting little pattern. Let me check my comments here. I see someone named Jill said you tried the viewer on the tape. Well, did it work? Did the viewer work on the tape against a computer screen or other white object? Let's see. Haven't heard yet, but that's okay. All right, so let's talk about invisible light. You have ultraviolet, comes from the sun, or an ultraviolet flashlight, also called a black light, that you can use with your ultraviolet beads. You have various types of infrared light. The kind that comes from the remote control is very close to what a human eye can see, and that's really why ordinary cameras can pick it up. The kind that comes from a hot plate or a coffee cup warmer is what we call far infrared, or just heat, okay? And in fact, interestingly enough, animals have developed the capacity to see some of these invisible colors. For example, bees, butterflies can recognize the different colors that flowers have in both visible and in ultraviolet light. So they're sensitive. And if you're familiar with snakes, snakes use the heat waves generated by warm-blooded animals to hunt. And for example, a mouse shows up as a glowing object to a snake. And at night, they can see the mouse, even though there's no visible light. It's only the infrared light, and they find their meals that way. Now, I promised that I was going to explain how these viewers actually work. And I'm going to try to give you the simplest explanation I can come up with. But remember what I said about the CD and the bubble. The bubble is a very thin layer of water, and the light interferes with itself as it goes and hits each of those layers, and that helps separate the white light into all the colors. The CD is thousands of little circular rows of depressions or more reflective bits in the metallic surface, but the key is they're extremely close together. Very close together on the same level of closeness as the walls of the soap bubble are. Okay, and the reason that the CD splits up the light is it involves very closely spaced objects. Now, the reason that your bits of tape will work with a viewer, okay, is that they're very thin, and as the light goes through it, it actually changes speed, okay, and gets deflected a little bit. But the odd part about tape and certain plastic objects is that it actually changes speed depending on how much it's twisted. So it's like a two-speed changer. And if you spin the object around or spin the light around, it will go through at different speeds. And when it hits the other side, it is in effect allowing the light to interfere with itself and bring out the different colors. Now, let me show you. This is a crude illustration of what a light wave might look like. Light is waves, somewhat like water waves, but you don't need water. And if you think of it as going up and down, well, that's partly correct. But think of the light wave coming to you. It turns out that the light, each of those waves is randomly twisted. Okay, so it's coming toward you, and there are multiple waves, or actually particles as well, that are twisted. And what that Polaroid viewer does is, in this case, I'm pretending like I have two viewers, and I'll explain why in a second. But one viewer only allows light that's vibrating in this direction, okay? And the other viewer only allows light. I mean, they're actually the same. I've just twisted it, okay? And the light that vibrates up and down can go through, but the light that, it can go through one that's vertical, but it gets blocked by the other one. So it selectively picks out light that's twisting or that's vibrating only in one direction. And it turns out that computer screens, TV screens, and light from reflected objects like the pond on a water or water on a road, or many reflected objects actually cause the light to eliminate everything but light coming in a certain vibration direction. And that's why we only need one viewer to view your polarized light art, because you already have light that's bouncing up and down from your computer screen, and the second one can selectively block it based on how you turn it. And that's what allows you to create different colors by your thin film. And that's the key. There's two things: twisting and the thinness of the film that it goes through, that allows the light to jump around a little bit. Now, let me see where we wanted to go next. Are there any of the experiments that you didn't get to see, or they didn't show up as well as you'd like, that you'd like to see again? Just type your comment and I'll look for it. Would you like to see how to make your rainbows? Questions about how to do bubble viewing and study. Oh, I did forget to mention one thing. If for photography purposes, I add a little glycerin, and some people use corn syrup to the soap and water mixture, and that makes the bubbles last a little bit longer. If you're not taking a photo, it's not so important, but you can experiment with different mixtures. Plain glycerin or plain corn syrup, just a little bit, don't overdo it, will make the bubbles last a lot longer. And you can get some very interesting photos, and you don't need special lighting or anything. Really, just a black background allows you to get some really nice photos. A cell phone camera is perfect for that. Let's see, do I have any other questions? So what I would like everybody to do is to take your viewer and start looking at stuff. The important part about it, well, first of all, don't look at the sun. Okay, if you go outside, don't look at the sun. But you might look at the sky away from the sun. And what you will see is that because light coming from the sky is partially polarized, the sky may darken as you rotate the viewer while you're looking through it like this. You may see the sky darken compared to the ground level. And in fact, photographers use that to make a more dramatic blue sky effect. That's why they sometimes use a polarizing filter. The other thing is you might try looking. I just take a piece of plastic and hold it so that you're getting reflections, And then as you twist it, see if you can make the reflections disappear. Just hold it so it's reflecting out a window, for example. And as you twist it, you can make the plastic visible or you can make the reflections visible. And there's a lot you can do with that. Besides, it's handy to have sunglasses that way because sometimes it's easier to drive if you don't have a lot of reflections off the road. But you can also use that to do some trick photography and make things appear and disappear by just arranging clear plastic or glass and changing where the light is, and then using a polarizing filter to make things, as you twist it, appear and disappear. Is anybody going to use the black construction paper to make art designs? Anybody? Didn't hear from them. Well, if you missed anything and would like to see this again, this event's going to be recorded, and I actually have a longer video, actually using a better camera, but that's also available on my YouTube channel that you can view. It's also called Playing with Light. That's pre-recorded. It doesn't have any, it's not interactive, but you can look at that. And it also attached to the description for this video are some other resources where you can learn more about how polarization works, learn how bubbles work, and how you can take this a little bit further. There are some commercial artists who actually design polarized light art for sale, and they've done some amazing things. And I'm hoping that some of your creations, I didn't ask the library folks, but if someone has a creation, I bet they could bring it into the library. And I know the library has a Polaroid viewer, and they might be able to share it with the staff or with the other patrons, because in person, these are, particularly if you have a large screen TV that you set to all white, can be quite spectacular. Well, thank you all very much for coming, and I hope you enjoy working with your kit. Okay. Hope to see you again. Bye.